The next notebook here will be on the NearSpec MOS MSA Metafile. All right, so it's necessary for the pipeline to tell it which shutters were open and what sources they correspond to. It has three components that I'll detail, and it's based on how you set up the observations in APT. And I'll mention a few reasons you might want to know about this file a little bit and edit it. For example, if you just want to process a subset of the sources, it can make things go a lot quicker. And otherwise it takes longer to run through all of them. You can also define which shutters are for science and which are for background. So this can be useful if you want to do master background subtraction. Then you also can define in this file which targets are point sources and which are extended. This is used by the pipeline in the path loss correction. It's either a point source or it assumes it's uniformly illuminated, so sort of the two extremes. Yeah, as you were setting up your APT observations, you included a stellarity in your catalog. But I know how much work it is preparing these APT observations, and you might not have set that up just right, or you might want to tweak it afterwards and see how it affects things. So you can do all of that here. And then finally, I'll show how to view this shutter image map, showing where all the slits and what sources they correspond to. Right, and then here's a couple of other notebooks where giving examples of where you want to edit the MSA Metafile. So NSClean, and then also I should have added here the master background that Kelly will present. All right, so we'll start out by importing some libraries here and defining a few functions. This one is especially useful for filtering the table, as I'll show. And then here's Astro Query to download files from MAST with a helper function here, and more helpers to download files and also link to files, and I'll show why that's important here in a minute. So for the MSA Metafile, if you know the file name, you just go ahead and put it in. You can skip this section, but the name of the metafile is included in the FITS header for your data, and so I think it's in pretty much every file. Here we're going to continue looking at this source 6355. We're going to go ahead and download the data from MAST. And then we're going to look in the header for that metafile, and here's the name of that metafile. And then we're going to go ahead and download that from MAST. Now let's have a look and see what's in there. So there's these 4 extensions. The first primary just has some information in the header, the observation date and a few things like that. And then the main bulk of it is these 3. I'll show this one last at the end. First, I'll show the source, the catalog, and then also the shutter. These are both tables that we load in with this AstroPy function. All right, and yeah, you could load this as a data model, but it doesn't really give much more than what I showed there. So the first thing is the source table, your catalog. As I mentioned, the stellarity controls the what type of source it is, whether it's point source or extended. And this is the range when it's extended. If it's higher, like 1 or 0.9 or 0.8, then it'll be a point source. Also, if it's a negative value, it'll just assume it's a point source by default. And that's so that's one of the things in here, one of the more interesting ones, I guess. And then for each source, you also have the RA-Dec, and then some alias. Here it's just the RA-Dec. There was no other alias in there. And you'll see there's positive and negative numbers. So these are for sources that were in your catalog. And then for other regions, if there wasn't a source there at that shutter position, then it assigns it a negative source number. It just makes these up, starting from, I think it's -1. All right, then the other thing is the shutter table. So this defines which slits, or it summarizes which slits are open, which quadrant they're in, which row and column, and whether they have a source in them. and whether they're background or primary science. And then this can actually, the MSA Metafile can actually have multiple configurations in it from multiple observations. So the first one is always number one, but there could be multiple ones in there. And so here's what this looks like. It's a bit truncated, but you see there's two different configurations in there. I think they're both the same in this case, but they're both in there. We have the shutter quadrant, row, column, source ID, and scroll a bit more over here to see these other things. This one is useful for the extraction, the estimation of where the source is in the shutter. And there's the three different dithers in there too. And so you'll see here, for example, this one is here on dither 2, this is the primary source. And then if you go to dither 1, the first dither, this is the primary source, and the other two are background. All right, so here are these multiple MSA metadata IDs. And the way these are numbered is they start with 1, and then they number all the slits. So here they're from 2 to 75. You'll see these in a second. These are all the slits that were opened. And if there are multiple slits, they can be combined into one long slit, as you'll see. And then they go to the next MSA metadata ID at 76. And so this is the shutter table again. If we now we're going to use this function just to show a subset of the contents a bit more clear. We're going to just restrict it to that first configuration and just the first dither position, so you can maybe see a bit more clearly what's in it for just a one dither. You get the row and the column and the X and Y, and if it's a primary source or not. All right, so now we're gonna start to edit it. Now we're gonna just trim it to a subset of the objects. These are some high redshift galaxies in there that we might want to process a few times and tweak things and see if things improve. So now we're going to send these through this handy helper function, and it's really simple. So we'll just filter these out, selecting these source IDs for both the source table and the shutter table. There's other things you might want to do. You might want to set the stellarity to 1 and say they're all point sources, for example. Or you might want to pick and choose and set some of them to different values. And then you might want to change which ones are background or primary source. I don't actually do that here, but Kaylee will demonstrate that in her notebook on the master background. All right, so here's our modified source table. It just has these 6 objects now in the catalog. And then we'll also show the modified shutter table. There's fewer slitlets now. And here we're just going to show a truncated version filtered out with like we showed above. All right, so now here's where we save the modified MSA Metafile, and just using some fits functions here, and we save it to this new file. And you'll see, so this is the original, and this is the modified truncated version. You'll see here now there's just the 6 objects compared to the 119 before, and there's fewer shutters than there were before. So now, once you have this new metafile, there's in order to run it in the pipeline, this is the way I like to do it. I create a new directory, and then this output directory, and then I link the rate files from that directory back to the originals. The way the pipeline works is it looks in the rate file header for that MSA Metafile. So I've gone ahead and I've kept the name the same. So I put it in this directory, and then I put links to all these other files in that directory, and I'll run the pipeline from this directory. So I don't have to edit the rate file itself this way. It just looks in that header, it finds this name, and it just looks in the same directory where it is and finds this modified MSA Metafile. All right, but we want to actually run the pipeline here. I covered that in the previous notebook. So that covers how to edit it. The last thing I'll show is just this last extension, this shutter image. Let me skip ahead first and just show you what it looks like. So this is the the rows and columns, they're transposed the way you would normally think about it. Normally rows would be going this way, but this is the way they're defined in here. And these are the different slitlet IDs. So going from 2 up to 75, I've color coded them here. But it takes a bit of work to get here. So the way they're encoded in the MSA Metafile is not the same way that they're oriented on the sky. But once you figure all that out, it's just really a few lines of code to sort of reorder things. This is the order they are in the file, and we just reorder them. Sorry, this is the way they're in the file, and this is the way they actually are on the sky. And just to show what that looks like in APT, let's see, do I still have it up here? So this is for that ERO program. These are the shutters that were open in this observation. And if you notice on the top here, there's these numbers that I was never quite sure what they were until I finally stared at them for this exercise. And there's two versions. This one resets for each quadrant, and then this one is continuous, as I've shown in the notebook. So this starts up here with 1, 1 and goes all the way down to, if I zoom in here, you can see this is the last shutter, 730, 342. But you notice the one on the left resets, so 365 and 171. Those are how many are in each quadrant. So as you scroll through, you might you could see which it tells you which quadrant you're on, and then it also shows you those numbers that either reset or not. So here I'm showing the version where the numbers just go all the way up to, what is it, 730 and down to 300 something. So that's from so that's the shutter image from the MSA Metafile. You could also reconstruct it from the shutter table. It has the same information in it, the row and column for each slitlet ID in the table. And we can do that with a few lines of code here. It took a minute to figure out how to do it exactly, but here are those lines of code. And then once you do that, you get this, which is similar or identical to what I showed above, just in a slightly different format. And then finally, I'll compare what we can get from APT. If you export, if you go into the MPT and you export the configuration, you can also get a CSV file that it's just a big 2D array that says whether each shutter is open or closed. And so here I show how to plot that up in the same way. So this time you're not getting the slitlet IDs, but you can see this, if you match it up to those above, it looks identical, showing you which are open or closed.